Okay, here we go, folks. All right, this is going on the YouTube, so let's go. We're gonna go do page. We're gonna do page 101, number 19. It's a challenge problem. A grocery set can withstand a maximum of 230 newtons before it rips. Okay, will a bag holding 15 kilograms of groceries that's lifted from the checkout counter at an acceleration of 7.0 meters per second squared hold? So they've put a heavy cantaloupe in it and whatever. They're pulling up on the bag really fast. Obviously, you guys have never heard of paper bags, but when I was a kid, there were paper bags. All right, Alejandro, that's great. So here we go. The first, the first thing to do to conquer physics problems is to draw a. Thank you. So let's draw our shopping bag. Okay. And in the shopping bag, we will put a cantaloupe. And it was 15 kilograms, correct? Okay. So we know that the acceleration being pulled up on the bag is 7 meters per second. Okay. Positive 7.0 meters per second, right? All right. We drew a picture, and we also know that what is the sum of our forces? What's it called? Net force. So whenever we are working with forces, we're always talking about net force. So what are the forces in this problem? Well, how do you move the bag up? Somebody has to pull it, right? So that would be called your F applied force. Okay? The applied force is pulling the bag up. Well, what other force is there? You got pulling the bag up, and what else do you have? What's pulling it down? So is that called weight? All right, so force of weight. All right, folks. Now, since the bag is moving up at 7 meters per second squared, right here is acceleration, right? Is that the applied acceleration? Is that, well, we know gravity doesn't go that way. We know gravity goes this way. We know gravity is negative 9.8 meters per second squared. What is that? Is that the person pulling? Is this gravity? Is it net? Which one? Well, let's think about this. Does the thing have weight? Does the person pick it up? Okay. So if you have the person's applied force and gravity both acting at the same time, do you need a net force in order for the bag to move? You always need a net force in order for the bag to move up. So the bag moves up with an acceleration of 7 meters per second squared. So this movement of the bag up is made possible by what? Net force. The net force is what creates movement. See, that's where you guys are not understanding. That's where you guys are in your middle school mind, because in middle school we taught you that force makes something move. But now, today, I'm telling you net force makes something move, because there's always other forces you have to calculate. Okay? So gravity's pulling it down, somebody's lifting it up, and the resultant of all that is a net force. So what is this acceleration then? Is that a person's acceleration? Is that the gravity's acceleration, or is that the net? Nope, that's the net. No, that's the net acceleration. That is the resultant. Yeah, man, but what? Why does acceleration have to be negative 9.8 meters per second? Why does it have to be that? That's weight. Okay. So, no, 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 no. The net acceleration of all that, the pulling up, the net acceleration, we don't know what the acceleration of pulling up is. We just know the bag's moving up at 7 meters per second squared, accelerating, right? Okay. So, since that's a net acceleration, right, then that goes here, doesn't it? All right, well, what's the equation for net force? Net force equals what? Mass times acceleration, doesn't it? It doesn't have to equal mass times gravity. It has to equal mass times acceleration. Okay, so let's do that. Let's do right here, under it, 15 kilograms, okay, times 7.0 meters per second squared, right? Now, does it say in the problem how hard the person pulled on the bag? It doesn't. We're finding that. What's the weight of the bag? How do we get the weight of the bag? Mass times gravity. Okay. Well, I know. Sorry, it should be plus. But that's okay because Ryan, it's going to be negative, right? My man, my man Ryan Woods, my man Ryan Woods, Ryan in the woods. Okay. Look, there's my applied force, which I don't know. Okay. And it says weight. Well, how do we calculate weight? Weight's in newtons, right? Okay, well, weight is mass times gravity, correct? Is that right, Ariana? It is right. So right here, we do 15 kilograms times negative 9.8 meters per second squared. Okay, calculate this part. What's 15 times 7? 105 newtons? Okay, so our net force is 105 newtons. We don't know the applied force. What's 15 times negative 9.8? Eh? 15 times negative 9.8? Negative 147. Solve for applied force. You just add both sides, yeah. Okay, Chris Perrin, what's the applied force, man? $252. All right, so 252 is the applied force, 252 newtons. And the bag says you can't yank on it harder than 230 newtons. So did it break? Yep. So 252 newtons is greater than 230 newtons. So the bag ripped. Yep. How many of you have done that before? Done that before, Alejandro? Did you ever put the canned drinks in the bag and then go yoink and then it rips? Okay. So, what have we learned here today? What have we learned so far? Net force. There isn't a movement unless it's a what being applied? A net force. A net is all of the forces accounted for. You must always write, not necessarily all that, but you do need to write down net force. Net force. We had to figure out the applied here because we already knew the net. You cannot have an acceleration somewhere unless it is a net force. The overall resultant acceleration is the net. Yes. Okay. The net force. Okay. Now, just for practice, I want you to do numbers on this page here. Yes, Ariana. That was 19. We did that together. You right now are going to do 16, 17, 18. Okay? With nice pictures. And let me tell you something. Okay? I know these problems aren't that challenging, but I want pictures. As you all have seen, no, do it right there in your notebook, man. As you all have seen, ladies and gents, these problems got a lot more difficult than you anticipated at the beginning of the semester. So pictures are required, okay? Pictures are required.